AP physicists, we're going to go ahead and get started. We're going to just kind of cruise through today. I know that everybody's excited. Oh my gosh, I'm excited too. We've got some stuff to do and it'll just make our day go faster, right? Better to have a fast day than a super slow, painful day. So, your opportunity for a little cultural awareness today, it is the Ides of March. Ides means the middle of March. I don't know if you've heard that term before, but it's one of those things that at some point in your life, you're going to be sitting playing Trivial Pursuit and your little piece is going to be on that pink pie. And if you know this, it might get you that pie and give you all the glory of the game. So I want to make sure that you understand it because it's important. It's just a little cultural reference. So Julius Caesar, he was a great ruler, blah, blah, blah. There he was also assassinated because he was also kind of a jerk. Anyway, yeah, right? Like bad news. So anyway, the story goes, and it's a true story, right? That there was a soothsayer, which is essentially like a, person with premonitions, that kind of person, came up to him earlier in March or something like that and said, beware the Ides of March, right? Beware the Ides of March. Watch out. And he was all full of himself and like, whatever. And then got stabbed in the back on March 15th. There you go. So, good, bad, or indifferent. I'm not going to get into that, but it's one of those cultural references that I feel like if I can give a little bit to you in that way, it's beneficial. So there you go. Welcome to the Ides of March. Hopefully nobody told you to beware. If they did, we'll watch your back today. I don't know, at least while you're in here. Okay. So yesterday we spent a good deal of time talking about circular motion. We spent a good deal of time talking about how that all relates to everything. And today we're going to put some numbers with it. So pull out some notes because you will need some today. Pull out a calculator because you will need one today. We're going to jump in and get started. Yesterday, we defined a new word, an important word, and a word not to be confused with another word that's very similar, right? The word that we defined, I will kick you out of my classroom. Don't push me because I will. I've done it before. Yeah? Centripetal acceleration. The word centripetal means what? Center seeking. Center seeking. Acceleration means what? Change in velocity. So this is a change in velocity that occurs when an object is moving in a circle. So this is uniform circular motion. I just like to call this UCM because I'm lazy. Okay? Uniform meaning that it's a constant speed. Now, is it possible for something to be in non-uniform circular motion? Yeah, like all the time. But then you have to talk about acceleration in terms of speeding up or slowing down angularly, which we can do. But we don't usually talk about it at the same time that we're talking about the forces that are acting in this way. So they're kind of like two separate things dealing with the same kind of related motion. When we're talking about uniform circular motion, though, just to be very clear, that means that it's at a constant speed. And I carefully chose the word speed here because can you put the word velocity here? You cannot, because velocity has both size and direction, magnitude and direction, right? So it's constant speed, circular motion. We're going around in a circle. Because we are changing direction, though, we are absolutely and for sure accelerating. But this uniform circular motion acceleration is always toward the center of the circle. Okay? So this is about as far as we got yesterday. We can quantify the acceleration, okay? We can calculate how big it is so we can figure out the magnitude. This was the direction. We can quantify the magnitude. I'm just going to tell you the equation. Doing the derivation does not take a long time, but it's like a 10 or 15 minute conversation that I didn't want to spend today because I want to make sure we get to problems today. Does that make sense? If you would like to see it, I'm super happy to show you. But the result of it, and the thing that I really want you to know and to internalize, is that centripetal acceleration, which is marked A sub C, is dependent on both the velocity or the speed of the object and the radius, how big the circle is. A sub C is equal to V squared over R. Okay. How are we doing? So far, so good? Okay. What's that? This is tangential velocity. Yes. Thank you for clarifying. I appreciate that. Yes. Yeah. Okay. The other little piece and step in here that we will get to, and we're going to do some problems just with centripetal acceleration to start, but I just want to get kind of all the notesy stuff put together here, is that any time that an object is accelerating, what do you know about the net force acting on it?
It's not equal to zero.
It's not zero, right? So anytime you've got something moving in a circle, there has to be a net force. So there's a net force causing the centripetal acceleration. That's how I talk about it. I always say that there's something causing a centripetal acceleration. Some people, some textbooks, some things that you will see will say there's a centripetal force. The reason that I don't say that is because then people start to write down centripetal force as a force on a free body diagram. That is a terrible plan. It's a terrible idea. You should never, ever write down centripetal force on a free body diagram. You remember we had that chart so long ago where we were listing forces, right? And so we had like the force of the earth on something Fg, the force of a string on something Ft, the force of a surface on something Fn. You remember this whole thing?
Yeah.
Right? So you can do that, and in each of those cases you're describing an object acting on an object. Life is good. The problem with calling it centripetal force is that it's not just one thing. Like every time it's a tension force, you know it's a string, okay? A centripetal force can be caused by any number of things. Any of those forces that we had on that chart could be a centripetal force if it's keeping something in a circle, okay? So I am going to talk about centripetal accelerations and just know that there has to be a force that causes that centripetal acceleration. The net force causing a centripetal acceleration, F net. Hey, F net is just equal to MA. It just so happens that A is a centripetal acceleration. That's all you need to know. This is the piece that makes it all go together. Okay? That is the new content for today. But I've got a bunch of problems for us to try. Ian's like, that's a lot of problems. We'll get through as many as we can today. We'll see. Issues or questions before we get started? All right. Here we go. Oh, let's not. Yeah, let's do this one. It's kind of throwing you a little bit of a curve just in that we haven't really talked about it, but I bet you can figure it out. Rank in order from largest to smallest the period of motion for the particles A to D. This is some thinking. I probably should have thrown this one in earlier, but that's okay. I bet you can figure it out. I'm going to pause this for a minute so you can have a minute to think. All right. Let's see some boards. Let's see what we've got. Let's have a conversation. All right. We've got C, A, B, up A, D.
Yep. That's still you got it.
B. Cadba. Bad. Cadba. But you want the upside down one?
Yeah.
So you want C, Hey, that's really, no, I don't think I can. Am I doing this right? Is that what you want? Do you guys match?
We made our C down. We're still equal to each other.
All right. So we have three answers. 4 answers? Did I get everybody's? I think I got everybody, yeah?
Yeah. Retract our answer.
You're retracting your answer?
We did it backwards, but we did it
Okay,
backwards.
well, regardless if you got it right or wrong the first time, because that's really not what I care about. The whole reason we do ranking tests is to have the conversation, right? So let's have a conversation.
Okay.
Talk it through with me, because there are undoubtedly people in here that are like, I don't know. Help me out. Where did you start? Get started. Go ahead.
Angular velocity is equal to tangential velocity divided by radius.
Okay, wait, hold on. So the angular velocity is equal to tangential velocity divided by radius. Okay. I mean, that's not inaccurate.
And the higher the angular velocity.
Friends, can I have you be quiet so that I can hear at least? And maybe there are other people in the classroom that actually want to hear also. So share the love, even if you're like a little wired because it's the last day before break. Like, I get it, but let's do some physics here so we can get through our day. Yeah. The higher the angular velocity, the lower the period. Why?
Because you're simply going around the circle faster.
Does that make sense? Angular velocity is related to frequency, right? Does that sound familiar to you? Angular velocity and frequency are kind of one and the same with that 2 pi, or tau, if you will, in there. So if the frequency is going up, the period's going down. So that seems reasonable. So that means that we just have to look at the relationship between V and R. And we've got a V and R for A, and we've got a 2V and 2R for D. So those are going to be essentially equivalent. If V gets bigger, then this is going to get bigger, which is going to make T smaller. So in B, that's going to be the small one, I think. And that would leave C to be the big one. So I think, hold on, I have to make sure that is, so this is what I'm agreeing with. Is that right? Cool. Hi, thank you. These are all.
This is everything about you. Yeah.
You didn't take it. That includes everything. So you can get an equation sheet if you want. Yep. All right, team, you ready for another one? Yes, please. Here you go. All right, more ranking tasks equal more fun. A block on a string spins on a horizontal circle. So this is like the imaginary circle that I was telling you about with my yo-yo from Dollar General, right? Okay. Rank in order from largest to smallest. The tension acting on the block. So the tension is the force on the string, okay, that's causing the centripetal acceleration. All right. I'm going to let you talk, discuss, rank, commit. V squared over R. For those of you that are feeling a little stuck, I don't want to just like leave you out to flail. So I just want to like kind of push you in a direction that may be helpful here. So Ft is equal to ma sub c, right? Because the net force acting on this thing, you've got gravity pulling down and the normal force pushing up. We don't care about those. So tension is the net force, which is causing the centripetal acceleration. So Ft is equal to mv squared over r. This is going to be like a thing that you're just going to have to kind of keep in your brain, right? Like that's going to be what it looks like a lot of the time. Not sure what to do with that frequency. Well, you can turn it into rotational stuff if you want. But if you don't love that rotational stuff, we can think about it another way as well. And I just want to draw your attention to this so that you are aware of it, right? Velocity, oops. I was going to write it over here. No, I'll just write it down here. Velocity is distance over time. If you're talking about something going around in a circle, how far does it go around if it goes all the way around the circle? 2 pi times the radius, right? So you can say the velocity is equal to 2 pi r. And how long does it take for it to go all the way around in a circle? What do we call that? The time it takes to go all the way around? Period? You could also write this as V is equal to 2 pi r times f, right? So then you can throw these two things together, and you can say ft is equal to m times 2 pi r f, that's all squared, over r. Are you with me there? Cancel out one of those r's. Okay? I'm gonna leave you there for just a moment to rank your ranking task. Courtney, you look really upset. No, you can totally ask the question that is going through your brain, though.
Well, did we cancel out? I was just thinking about the last time when we were talking about rotational kinematics.
Yeah.
It had so omega is equal to 2 pi f, right? Because there wasn't an r in it.
Right. And this is V.
This is just V.
So,
Yeah. Okay.
yeah? Yeah. So you put it all together. You just you kind of have it in two columns.
Yeah.
But yes, what you just said puts them all together. Yes, that's exactly right. Okay. So maybe just another moment. Get it ranked. Go, go, go. If you have not done so yet, get it ranked. Rank it up. That's going to be a thing. I want every single person to try and write this down. Whether it's on a paper or on a whiteboard, I want you to own it. I want you to understand it. I want you to do it. You can absolutely talk to each other. I love that. But I want you to get it.
I'm actually writing.
He's writing down. There's not tablets, but my calculator.
I'm gonna use.
Yeah, it's Alvin Ford.
Alright, so we've got 100.
So now it's just like a new language, right? It's like how you're doing this. Jacob, I'm sure that the readers will appreciate it if you do that on your test. They'll be like, what is this? Oh, wait. Smart Alec.
Oh, it's house square.
House.
There it is.
Oh my gosh.
House square over 4.
I'm right. But then
Where does mass go? Nowhere. Not yet.
That 2 tau. 1.2 times tau squared.
Yeah.
So 1.2 times 2 pi squared.
2 squared pi squared. 2 squared pi squared. Don't forget that other squared.
yeah, so I am going to
Can we have pi and pi square?
Yeah, yours is
yeah,
47.
Can't we all just get along? Hey there. How's it going?
Actually,
You didn't divide it by 4.
I have to leave before school ends, actually, today.
okay.
Yeah.
2.4
Do you, I mean,
squared.
I was wrong.
You're wrong.
It's
I mean, the short answer is no.
Yes.
What did you get on your first test?
I mean, what was that?
It's 1.2 tau.
How? I think I got like 5.
So I got 432.
Why are you talking to me just now?
Nice numbers.
I feel like this is the second time in a row that we've done this, right? Yeah, what's the deal?
No, Reed, you're wrong.
I
I was right. This is the answer.
mean, I can't be here after school is the short answer. If you want, I don't really want to do it. Let's do it after break. Why don't you talk to me on Monday? Don't forget, okay? Leave yourself a note. Have a good break, babe.
To calculate omega, which is ends up being 4 pi. And then,
Are we there?
velocity equals omega What'd you get?
I'm getting it.
Velocity equals omega r.
Wait, it didn't be math stuff?
This one, that's
Yeah.
square.
You guys like really.
I got a huge number.
Hold on. I got
You were like
94.75.
I was telling you no.
What'd you
That's
get?
not what I meant.
39,400.
What is not?
You put it three. You put one.
I got 94.
Yes, and then I was trying to grab the board to erase it like 50
Square.
It's a big number.
Omega over
I'm not bad for that. You're bad.
I was literally trying to erase it the entire time. And you're telling me.
What?
Omega equals tau x, and then velocity equals omega r. So
40,000.
omega. Because you are given F. You're given. That's not omega.
That is omega.
You just
It's a measure of radius.
I wasn't trying to think about it.
It's almost like that's the frequency.
That's what I was
No, he
thinking.
says that is omega. You just have to multiply it by 2 pi.
It is.
So it's the frequency.